You know, being an athlete is way too difficult now. I mean, come on, everyone's insanely good and everyone has an edge. But do you know what most athletes do not do? Math, specifically calculus. So let us give you an athletic edge that nobody else has through the sports of calculus. Hey, calculus comes down to two main topics: derivatives and derivatives! Now, what is a derivative? Well, essentially, derivatives are the slope of a function at a specific point. It tells you how fast something is going and what direction. Now, let's break it down with this curve. In our first half, our graph is increasing, meaning it has a positive slope. And as you can see at the top, the graph is flat. You know what that means? That means we have a slope of 0. And after that flat point, we can see that our graph is decreasing, meaning we have a negative slope. Now, every specific point on our graph has a different slope, and derivatives capture that slope. On our derivative graph, our y values is the slope at that point on the original function. For example, at the top, our derivative, or our slope, is 0. With the corresponding x value on the derivative graph, our y value is 0. Great, but how do these relate to sports? Well, let me tell you. Sports comes down to two main components: agility and strength. Well, to help you visualize, let's look at an example of strength in sports through tennis. So come on, Karina, let's see those tennis skills. Oh, see, that was an example of minimal strength. Do you know how I could tell? Well, let's see Karina's swing in graph form. As you can see, our graph has a positive slope, a slope of 0 at the top, or at its maximum height, and then we have a negative slope. So basically, she lobbed. We can increase Karina's strength through the power of derivatives. See, I bet no one else thinks about sports like this. Let's look at the function that resembles Karina's lob. In this case, it resembles this function. Well, the slope up until x equals 6.235 is positive. And then the slope is 0 at x equals 6.235. And then after x equals 6.235, the slope is negative. Try saying that fast. This means all the y values in our derivative graph are going to be positive up until x equals 6.325. At x equals 6.235, our original graph has a slope of 0, meaning our y value on our derivative graph is going to be 0. Finally, after x equals 6.325, our slope is negative, meaning our derivative graph is going to have negative y values. So, after all that, look very carefully. Very carefully. What does it look like? Exactly, a strong serve. I mean, come on, look. Great job, Karina. Now, being the best sports player comes down to using calculus to elevate your player performance. So let's look at a more in-depth example of using derivatives in sports. So far, we know derivatives are slopes, but how can we use this in the real world? I mean, other than tennis, of course. Well, let's look at derivatives through running, specifically the derivatives of position, velocity, and acceleration. For example, let's say a runner's position in meters from the starting line after t seconds is given by this function. The position is where you are. For example, before any time has passed, all runners start at the beginning of the race, meaning their position would be 0. Hey, but you're probably wondering how any of this relates to derivatives. Well, guess what? The derivative of position is velocity. And who needs velocity? Exactly. Runners. Velocity, or the derivative of position, tells us how fast a runner is going at a certain point in time. In this case, let's take the derivative of s of t, also known as our position graph, which would be, essentially, the velocity in meters per second of this runner is given by this function. This function gives us our velocity in t seconds. Great, so now we know the position and velocity of our runner. But how does any of this calculus relate to sports? Well, the second derivative of position, also known as the first derivative of velocity, is acceleration. And acceleration is the rate at which the runner's speed is changing. And this function is crucial for starting a race. Now, let's analyze the acceleration again with calculus. We know that acceleration is the second derivative of position, also known as the first derivative of velocity. In our case, that would be, well, this means that the acceleration of our runner is 8. Or, in other words, throughout the whole run, our runner's acceleration is 8. Now, let's look at an example through some running. At the start of the race, 0 seconds have gone by, meaning that Zainab's position is 0. But as she runs, her pace will inevitably change. At the start of her run, her velocity and acceleration will be positive. Why? Well, it's because we're speeding up. Or, in this case, we're starting our run. However, later on in our run, our runner gets tired. Oh my gosh, so she begins to slow down. This means that all although we are moving forward, our acceleration slows down. But what happens when our runner gets very tired and needs to stop? Well, when she stops, her velocity becomes 0 because there's no movement. So since she's very tired, our runner's gonna go back to where she started so that she can get this run over with. This means when she runs towards her starting point, our velocity is gonna be negative because she's going back to where she started. However, our acceleration will be positive because she's speeding up. Do you see how everything's related? We may be going back to where we started from with a negative velocity, but our acceleration is positive because we're speeding up. Now, let's relate this to what really matters. Sports. If you want to beat everyone in your race, you must increase both your velocity and acceleration to surpass everyone in the race. Yeah, you're welcome. We just taught you how to beat every single bit of competition in sports. Because no one else relates sports to math. Come on, what athlete actually does math? Wait, no, what athlete does calculus? Please. No, I'm just kidding, you do. And that is exactly why you will become the best in your sport. But wait, before you go, let's take a little quiz to truly solidify your understanding. Oh, hey, you stayed until the end. Well, you know, if you're wondering who I am to tell you how to athlete, I know what I'm talking about. I mean, come on, look at me do hurdles.